Hey guys, in this video we're going to talk about M.1.10 and M.2.4. Okay, so the first thing we're going to talk about is M.1.10. So we're going to try to formulate inequalities and equations based on a situation. So just as a reminder, and actually maybe I'll make this a new page. So for inequalities, we have the following. We have greater than, which have this little symbol right here. And an example of how to use it, we could say that 5, so we read from left to right, we read 5 is greater than 1. Okay, so greater than, it's facing open towards the thing that's bigger. So it's open mouth towards the thing that's bigger. We also have less than. So an example of this is 1 is less than 5. Okay, and notice that this expression up here also says 1 is less than 5 if we read starting at 1 and if we read right to left, which we can do in math. We can say, well, 1, the pointy side is facing 1, so that means less than. 1 is less than 5. Okay, so these two statements right here are equivalent, actually. And then we have greater than or equal to, with that little line under the greater than sign. So this is greater than or equal to. And we could use this with this example. We could say 5 is greater than or equal to 5, right? So this symbol means it could be greater than or it could be equal to. So 5 equals 5. 5 is greater than or equal to 5. Okay. Then finally we have less than or equal to. So this is less than or equal to. Use the same example, or we could say 2 is less than or equal to 9. Okay, so these are just our inequalities. It's a reminder of how we can use them. Suppose Xavier attends a local fair. He spends a total of $25, which includes a $5 admission fee and 8 rides. When he returns home, his dad wants to know, how much does it cost for a single ride? So how can we write an equation or an inequality to represent this situation? Well, we know that he spent a total of $25, and that's going to add up to the $5 admission plus the cost of the rides. And how can we represent the cost of the rides? Well, we know that he rode 8 rides, but we don't know how much a single ride costs. So instead of writing the cost of the rides, we can write 8 times the cost of the rides. Cost of one ride. So R is the cost of one ride. Okay. And then we can go ahead and solve this guy, right? We can first start by subtracting 5 from both sides. So we get 20 on the left is equal to 8 times R. And then if we divide both sides by 8, 20 divided by 8 is going to give us $2.50. So each ride costs $2.50. Okay, Vivian is at the store and she wants to spend no more than $70 on groceries. Okay, so she wants to spend, how do we say this mathematically, no more? Well, it could be equal to $70. She could spend $70, or she could spend less than $70. So she wants to spend less than or equal to $70. Okay, so we'll start there on groceries. And she knows that she's going to spend $45 on necessities. But she also wants to buy pepperoni. And pepperoni costs $5 a pound. How much pepperoni can she buy while staying in her spending budget? So we know that she's already going to spend $45 on necessities. We want to add on the cost of pepperoni. Well, the cost of pepperoni is going to depend on how many pounds she gets, right? So it's $5 a pound. So instead of putting the cost of pepperoni here, we can just say it's $5 times P, where P is the number of pounds of pepperoni, right? So the cost of pepperoni is going to be 5 times P because we're paying $5 per pound. So does this make sense? Well, yeah. The left side, so this expression right here, 45 plus 5P, that's what she's going to be spending on groceries. She wants this to be less than or equal to 70. She doesn't want to spend any more than $70 on groceries. All right, so let's go ahead and figure out what P is. Now, we can solve inequalities just like we solve equations. We can draw a line through and just isolate the variable, which in our case is P. So that's going to be our pounds of pepperoni. So I'll start by isolating P by subtracting 45 from both sides. Okay, and I get 5P is less than or equal to 25. I'll go ahead and divide both sides by 5 to isolate that P. And I get that P is less than or equal to 25 divided by 5 is 5. Alright, so how much pepperoni can she buy? She can buy, what this tells us mathematically, is that she can buy no more than 5 pounds. She could buy 5 pounds, but she can't go over 5 pounds. Alright, so that's our answer there. Alright, Naomi decides to collect postcards. She starts her collection with 9 cards, and every week she buys 2 more cards to add to her collection. Write an inequality that would allow her to find how many weeks until she has more than 35 cards. So I'm going to start with this more than 35 cards. More than means strictly greater than. And on the left side, we'll include everything else that we're given. So she starts with 9 cards, right? And every week she buys 2 more cards to add to her collection. So plus 2 times W, depending on how many weeks. Right? Weeks is the variable here. How many weeks until she has more than 35 cards? Right? Because, you know, if the number of weeks, if W is 0, then she only has 9 cards, right? 2 times 0 is 0. So she only has 9 cards if there's 0. If she lets a week go by when W equals 1, 2 times 1 is 2, 9 plus 2 is 11. She'll have 11 cards, okay? But we want this to be more than 35 cards. We want to see, what does W have to be for her to have more than 35 cards? So again, you know, we're just solving this like we would any kind of equation. We'll start by isolating the variable by subtracting 9 from both sides. So we get 26 on the left side, 2W on the left, and 26 on the right. And I'll go ahead and now divide both sides by 2 to get W is greater than 13. Okay, how many weeks until she has more than 13 cards? Okay, so W has to be greater than 13. Okay, write an inequality that models the following sentence. 3 more than 5 times a number X is greater than 3 times the same number decreased by 9. All right, so let's take this step by step. First of all, I'll take care of the 5 times the number x first, okay? So 5 times x is just 5x. 3 more than that is plus 3. So we got the first part taken care of. 3 more than 5 times x is greater than. All right, so is greater than is just this. So this thing is greater than 3 times the same number decreased by 9. That means subtract. So this is our inequality that models the sentence. And we can solve for, the directions said just find the inequality, but let's go ahead and figure out what that missing number is. So I'm going to draw my line through the inequality sign, and I'm going to start by subtracting 3x from both sides. So I get 2x plus 3 is greater than negative 9. I'll go ahead and subtract 3 from both sides, and I get 2x is greater than negative 12. I'll go ahead and divide both sides by 2 to get x is greater than negative 6. Okay, so that is my answer there. Alright, so, let's go ahead and move on to this next problem. A car wash charges $10 for minivans X and $5 for sedans Y. The car wash spends $3 on supplies for each minivan service and $2 on supplies for each sedan service. Write an expression that represents the net revenue for the car wash. Okay, so the revenue is going to equal something, right? So how much the car wash is making depends on the sales, like how much money we're getting for the services. So we know that the car wash charges $10 per minivan. So if there's X minivans, we're making 10 times X, right? Plus $5 for sedans. So this is going to be 5 times Y, because we're told that however many sedans come through the car wash, we are going to call that Y. Additionally, it spends $3 for each minivan service. Okay, so the car wash is actually spending the money. It's not getting a profit in. So we're going to indicate the spending of money by a minus sign. So we're going to subtract away $3 times however many minivans come through. And we said that however many minivans come through is represented by X. We're also going to, the car wash is also going to spend money on supplies for the sedan service. So they're actually going to take away 2 times Y, $2 per every sedan that comes through. So this is how much revenue is going to come in. We have 10x plus 5y minus 3x minus 2y. And we can actually combine like terms here, condense it down a little bit. So these guys are like terms, these guys are like terms, and so our answer, our revenue, is going to be 10 minus 3, that's 7x, 5y minus 2 is 3y. So this is going to be our total revenue. I want to now shift the focus over to M.2.4. So this is all about geometry. So the first big definition we need to know is perimeter. And basically all perimeter means is the length around a shape. So if you have a rectangle like this and you're asked to find the perimeter, you just say, well, rectangles have opposite sides equal. So if this is 2 feet, this is also 2 feet. And if this is 5 feet, the opposite side is 5 feet. And to find the perimeter, you just add all the sides up. So the 2 lengths, 5 plus 5, and then the 2 widths, 2 plus 2. Adding all this together, we get a perimeter of 14 feet. Okay, so that's the length around the object. So circumference is just a fancy word for perimeter of a circle. So it's the length or the distance around a given circle. And this is an important formula to know for the T's test. It's circumference equals 2 pi r. And r is going to be the radius of the circle. Now the radius of the circle is the distance from the center to the edge. That's all that means. So this is the radius. Okay. Now, sometimes you'll see diameter, and diameter just means 2 times the radius. That's all that means. So find the circumference. We're given a circle, a poorly drawn circle that someone drew. It was me. Spoiler. But we want to find the total length around the circle. Like if we cut this circle and flattened out to make it look like a line, how long would that line be? That's what the circumference tells us. So we just follow the formula. The circumference is equal to 2 times pi, and our radius, the distance from the center to the edge, is given as 4 centimeters. So in place of r, we're going to put 4. And if I simplify, multiply 2 times 4, leaving the pi, I just get 8 pi. If I were to multiply this out in my calculator and round, I would get, let's see, if I do 8 times pi on my calculator, I get about 25.1. And this is a length, so it's going to be, the units are going to be centimeters. All right. So that's the circumference. All right. What if we have something like this? Well, this time we're given the diameter. The diameter is 2 of the radiuses, or the radii. So that means the radius is half of that. So half of 18 is equal to 9. So now we can use our circumference formula. Circumference is 2 times pi times the radius. In our case, the radius is 9. It's just half of the diameter. So we get 2 times pi times 9, 18 times pi. In my calculator, if I do 18 times pi, I'm getting approximately 56.5. Alright, so these are the formulas you need to know. These are all of the formulas for area, okay? All the shapes that you could encounter on the T's. The rhombus is debatable. It's not a very common shape that we find the area of, but I would memorize this just in case. So, yeah, so these are all of our shapes that we're going to be finding the area of, and these are their area formulas to the right. So, so yeah, just make sure you are memorizing all of these formulas before you take the test, all of these area formulas. And area is just how much surface space something takes up, okay? So like, if you're trying to find the area of a triangle, you're just asking yourself, well, how many little squares can I fit inside the triangle, in the two-dimensional triangle that lies flat on the page? So that's what area is. We have volume. Volume is a three-dimensional concept. So volume is how much space a 3D object takes up. So, you know, if you have a can of soda, and you're finding the volume of this can, trying to figure out how much stuff fills up the can. In particular, how many little cubes can fit in a can. That's what we're asking ourselves with volume. So these are all of the volume formulas that you need to know for the T's. Memorize all of these. Make sure you know them well. Then there's some examples right here, but we're about to do some more examples. So let's do that. So for this problem, we want to find the area of the shape. Now we can cut this shape into two different pieces. We can cut it into the triangle that makes up the roof of this house, and we can cut the rectangle off. And it's pretty easy to see what the area of the rectangle is because we have the dimensions. We're given that this little width right here is 8 feet. And let me actually do that in black. And we're given that the base of this rectangle, the length, is 24 feet. So that's pretty easy to find the area of that shape. Now what about the triangle? If we go back to our formula here, the area of the triangle is given by 1/2 times base times height. Okay, so that's what we need. The area of a triangle is 1/2 times base times height. Now, the base is going to be the bottom piece of this triangle, right? And the bottom piece of this triangle is part of this rectangle, right? It's the length part, and it's directly across from 24 feet. So we know that this purple part must also be 24 feet. So let's go ahead and label that. So now we know what the base is. Now what about the height? What about the height? So it's not immediately obvious what the height is because it's not explicitly it's not telling us what the height is exactly. But what we are told is that the height from the very tippy top of the triangle to the very bottom of the house is 12 feet. And we also know the height of this little piece right here. This height, since it's part of the rectangle, is across from 8 feet. So that piece is 8 feet. Okay? And so the point I'm trying to make here is, since we have the height from the very top to the very bottom, and we have the height from here to here, if we take the difference in those heights, it's going to give us just this little piece right here, which is what we were looking for. Let me do that in green. That's the height we're looking for. Okay, so we're going to take, let's do that. So we're going to take 12 feet, and from it we're going to take away this 8 feet. And the result is going to be this height right here, these green dots. Okay, so what is that height? Well, 12 minus 8 is going to be 4, so this little guy is 4 feet. So the height is 4 feet, and now we have everything we need to figure out what our area is. Okay, so the area of the triangle is going to be 1/2 times base, which was 24, times height, which is 4. 1/2 of 24 is 12, and 12 times 4 is 48. So the area of the triangle is 48 feet squared. The area of this guy is just length times width, so 24 times 8. And that's going to give us 192. Okay, so if I add these together, the total area is going to be 48 plus 192, and that's going to give us 240. And it's going to be 240 feet squared, right? Because if I left the units in, I would get feet, 4 feet times 24 feet. That feet times feet is feet squared. So that's my answer, 240 feet squared. All right, let's do another problem. The length of a rectangular fence is 3 times its, I think this meant to say width. Let's try that again. Let's write this down. Okay, so the length of a rectangular fence is 3 times its width. If the fence's perimeter is 200 feet, what are its dimensions? All right, let's take this step by step. Now, we have a relationship that we can establish. The relationship is between the length and the width. Now we don't know what either of these things are, but we do know that there is a relationship between the two. And how about we call W the width? We don't know what it is, but that's okay. And let's call L the length. Again, we're not told what these two things are, but we are told in the first sentence the relationship between the two things. It says that the length is, okay, so the length is equal to 3 times the width. So how do we write that? 3 times W. The length is 3 times the width. That's what that first sentence says. So let's put that in our pocket and save it for later. Now, the second sentence says, the perimeter is 200 feet. So the perimeter, let's just write this down, is 200 feet. And my question is, what are the dimensions? In other words, what is the length and what is the width? So the only two things that we have to work with are the length is equal to 3 times W and the perimeter is equal to 200 feet. So let's draw a picture here. Let's draw a picture of our rectangle. Now, if you can get yourself into one variable, that's what you want to do. In other words, I don't want to say, oh, this is the length, and this is the width, this is the width. No, I don't want to do that. I want to make sure that I have only one variable so that I can solve the equation, the perimeter equation. So which of these variables can I replace so that I'm in one variable? Well, I can replace L with 3W. If I replace L with 3W, then I only have one variable to worry about, and that's W. So those are the same thing. The length is 3W. The perimeter is 200 feet, and so what that means is that when we add all of these sides up, it should equal 200. That's what perimeter means by definition. So let's go ahead and do that. Let's go ahead and add all of our sides up. 3W plus 3W plus W plus W, and that all should add up to 200. That's just the definition of perimeter. Now we can combine like terms. So on the left side, 3 and 3 make 6. 1 and 1 make 2. 6 and 2 make 8. W is equal to 200. And let's go ahead and divide both sides by 8 to get what W is. So W is equal to 25. So we know W is equal to 25, so let's write that here. And now we want to know what the length is. Well, the length, we know, if we know what W is, we know what the length is, because the length is 3 times W. And we just found W. W is 25. So the length is going to be 3 times 25, which is 75 feet. So my dimensions, so my answer is 75 by 25. Or if you want to do it the opposite way, that's cool too. That's our dimensions of this rectangle. All right, what is the area of the shaded region? You might see something like this on the TEAS test. Let's talk about the strategy first. All right. Now, the shaded region is just part of this trapezoid shape, and we're eliminating the area of the circle inside it. Okay? So here's the idea. We are going to take the area of the whole trapezoid, including the circle that's in it. We're going to take the area of that guy. So we're going to take the area of the trapezoid, and we're going to subtract the area of the circle. Right? Because if I take the area of the trapezoid, it's going to give me everything, including this little circle in there. But if I take away the area of the circle, then I just get this remaining shaded region in green. Okay, so that's a strategy. So let's go back to our area formulas for trapezoid. Let's see. I just want to make sure that I'm using the letters that they like. All right, so here's our trapezoid area formula. We have base 1 up top, base 2 on bottom, and then the height. So the area formula is a half times height times the sum of base 1 plus base 2. Let me write it up here. The area of a trapezoid is equal to a half times height times b1 plus b2. Okay. The area of the circle is going to be pi r squared. Okay, so these are the two formulas we need to know. Now, let's go ahead and figure this out. We need to know what h is, b1, b2, and r, and then we're golden. Okay, so our base 1, I don't remember if, did they call the top one? It doesn't matter, but okay, they called the top one B1. I just want to be consistent with what they have in the picture there. So B1 is 9, B2 is, that's that top base, B2 is this bottom base which is 17.5, and our height of this trapezoid is 9 centimeters. Meanwhile, the radius of our circle here is 3 centimeters, so it's going to be 3. All right. So the area of the trapezoid, just following this formula up here and using these values, is going to be a half times 9 for my height times the sum of 9 plus 17.5. And then we're going to take away the area of the circle, right? We're going to take away the area of the circle. So the area of the circle is going to be pi times the radius, which was 3, squared. Okay, so let's go ahead and get some numbers here. So if I first do what's in parentheses, 9 plus 17.5, I get a half times 9 times 26.5, and then minus, I'll just do this off the cuff, 3 squared is 9, so this is pi times 9. Then I can multiply all of this stuff together. So 26.5 times 9 times a half, it's going to give me 119.25 minus pi times 9. Okay, so I'm going to put this in the calculator using the pi symbol, and making sure when you put this in parentheses to when you put this in the calculator, put this guy in parentheses. Okay, so what I'm getting is about 90.98. Alright, and that's going to be centimeters squared because we're dealing with area here, units squared. Alright, so that's my answer there. So we want to find the area of the shape. So again, I like to separate this into the two shapes. And so we have two shapes. We have the area of the rectangle, and then we have the area of the semicircle. So this half circle here that is wonderfully drawn. Not really, but I tried my best. So yeah, this is the semicircle that I'm talking about. So we have this piece of area that we're interested in, and then we have this piece of area that we're interested in. So let's work with the rectangle first. Now we know what the width is, but what is the length of the rectangle? What is the length of the rectangle? Well, the length of the rectangle, so the length of this particular rectangle is equal to the diameter of the semicircle, right? Because the diameter, by definition, is the distance from one edge of the circle to the other going through the center. And we can see here that the radius is, the distance from the center to the edge is 6 feet, which means that this little piece right here is 6 feet, which means that this little piece right here is 6 feet. So the total length of this is 12, right? It's the diameter, 2 times the radius. So the length of that guy is going to be 12 because that's the diameter of the semicircle. So the area, and maybe I should put my units and be good. So the area of that guy is going to be 8 feet times 12 feet, which is going to be 96 feet squared. So that's the area of just the rectangle. And the area of the semicircle is going to be the area of a regular circle cut in half, divided by 2. So it's going to be pi times r, which is 6, that's our radius, squared, and then we're going to cut it in half because it's a half circle. Alright, so we have 36 times pi divided by 2. Let's get a rough estimate here. So times pi, all divided by 2, and that's going to give us rough estimate of 56.5 feet squared. So the total area is just these two areas added up, the area of the rectangle and the area of the semicircle. So we have 96 plus 56.5. It's going to give us roughly 152.5 feet squared. Okay. All right, find the shaded region, the area of the shaded region. So this is very similar to the trapezoid example. Right, we had this trapezoid here, and we were trying to find just the area of that shaded region. So it's the same kind of concept. We have a rectangle on the outside, so what we want to do is we want to take the area of the entire rectangle, right, and take away just this inner rectangle's area to get the blue portion. So let's go ahead and do that. Maybe I should have showed you that in blue. So we're going to take this whole thing right here and then take away just this portion to get the shaded region. Okay, so the area of the big rectangle, this 12 by 10 rectangle, well, 12 times 10 is going to give us 120. So and it looks like we're in meters, so this is meters squared. And the area of the small rectangle is 7 by 2 meters, so area of this little skinny one, 7 by 2, is going to give us 14 meters squared. So we take the area of the larger, which is 120, minus the area of the smaller, which is 14, and that's going to give us 106 meters squared as our final answer. So how can we find the perimeter of this weird shape? Well, for the perimeter, we need all the sides to be there so we can add them up. Now let's just kind of mark off the sides that we have. We know that this is 6 meters. We know that this is 4 meters. I'm not really sure what that little height next to 4 meters is, but we know that this guy right here is 15 meters. And we know that this guy is 10 meters. So the two missing things are going to be in red. This guy is missing, and this guy is missing. So to figure out what those two missing pieces are, we need to use what we're given here. So one way to look at this is by breaking up these things into smaller pieces. So if I draw, for instance, a little dotted line right here, right? Well, I know from directly across that this purple section, from all the way to the top to all the way to the bottom, this whole thing, let me maybe make it a little bit more clear. This whole thing is going to be 10. Right? This whole thing is going to be 10. Okay. So from the very top to the very bottom is 10. But we also know that from the top to this point is 6. And so this point, this little piece right here, must be 10 minus 6, right? So 10 minus 6 is going to give us this little guy as 4. All right. So again, from top to bottom is 10. We were given from this point to this point is 6. And for this to add up to 10 from top to bottom, this point has to be 4. From here to here is 4. From here to here is 6. Altogether it makes 10. So that point's 4, so we have that covered. This guy is going to be 4 meters. And I'm going to change him to green since we just figured him out. Now the next thing that we need to figure out is this red piece up above. So let's see how we can reason our way through this based on what we're given. Try to redraw it a little bit better. Okay. All right. So in terms of length, we are given this bottom piece is 15 meters and this little piece is 4 meters. So I'm just looking horizontally at the length. And so if I know, like, let's maybe draw it a little bit more clear. If I know that starting here, going out to here is 4, right, because of this, right, this is 4. Then the rest of it is this red piece, right, because they're like directly opposite from one another. And altogether, it has to add up to 15, right? Because that's what we're told up here. From here to here is 15. Now, if this piece is 4, this piece has to be 15 minus 4, which is 11. So that red piece has to be 11 meters. Okay? Now we have everything we need to find the perimeter. Let's go ahead and do it. So add up all the sides. I'm going to start with here and I'm going to go this way. So then I have 8 meters, and maybe I'll just do the numbers here to keep it simple. So I have 11 plus 6 plus 4 plus 4 plus 15 plus 10, and that is going to give us a grand total of 50. 50 meters. That is our perimeter of this shape right here. Let's move on to a volume question. So we're given this box. It has a length of 1.5 feet, a height of 3/4 of a foot, and a width of 1/2 of a foot. What is the box's volume? So let's go back to our volume formulas. And we see that a box is the same thing as a rectangular prism. So we're going to use this top formula, length times width times height. So the volume is going to be length times width times height. And the length is going to be 1.5 feet times the width, which is 3/4 of a foot, times the height, which is, let's see. The width was 1/2 and the height was 3/4. Okay. Alright, so what I can do at this point is I can just multiply these guys straight across. So the volume is going to be 1.5 times 1/2 times 3/4 straight across is 3/8. Now 1.5 I can change to an improper fraction, right? I can just multiply 1 times 2 and add 1 to get 3/2 is my equivalent improper fraction there. So then again, multiplying straight across, I get that the volume is 3 times 3 is 9, 2 times 8 is 16, and my volume is actually going to be cubed, right? Feet cubed. That's how many cubic feet can fit into the box. And the reason we get that is because if I would have left the units in, I would have had 1.5 feet times 1/2 a foot times 3/4 of a foot, and feet times feet times feet is feet cubed, So that's how we get that unit for volume. So an orange has a volume of 4 pi. What is the length of its diameter? So the orange is closest to a sphere. I mean, you know, obviously oranges aren't perfect spheres, but close enough for estimation purposes. So if we go back to our formula sheet, we see that the volume of a sphere is down here. 4/3 pi r cubed. Where r is the radius again. Okay, so they tell us what v, the volume, is. They tell us that v is 4 pi, and we want to know what the diameter is. Now, keep in mind that the diameter is 2 times the radius. So if we know the radius, we automatically know the diameter. So let's go ahead and figure out what the radius is. Now, I'm going to go ahead and sub in 4 pi for v and just leave everything as it is, because 4 pi is literally the volume. We can just make that substitution. Okay, and so we want to isolate r, just like we would in any normal algebra problem. And it might look weird, but it's okay. We can do this, guys. So on the right, since I'm trying to isolate the r, what I'm first going to do, since everything's being multiplied on the right side, I'm going to just start by doing a simple division by pi on both sides. And the reason I'm doing that is just get rid of it. I don't want it. So when I do that, on the left, it cancels out and I'm just left with 4. On the right, it cancels out and I'm left with 4/3 times r cubed. And at this point, I want to isolate r cubed. So what I can do, and maybe I'll actually rewrite this to make it a little bit more clear, is I can just multiply by the reciprocal of this to clear out to 1. Or if you prefer, you can divide both sides by 4/3, but note that that's the same thing as multiplying by 3/4. It's literally the same exact thing. So that clears on the right. And on the left, if I cross simplify, these 4's can actually cancel out, and I'm just left with 3 on the left equals r to the 3rd on the right. Now, how do you get rid of a square? You square root. How do you get rid of a cube? You cube root. So I'm going to take the cube root of both sides to get rid of that cube right here. And that's going to go away, and I'm going to get r is equal to the cubed root of 3. Now, it asks for the diameter, which is 2 times r. So my final answer is going to be 2 times the cubed root of 3. And if we want to, we can make this into a decimal, but for our purposes, I would just leave it as is. And by the way, since it's a diameter, our units are going to be units of length, but we're not given specific units here. So this is our answer. Alright, let's do one more problem. Cylinder A has a radius of 4 inches and a height of 2 inches. Cylinder B has a radius of 2 inches. What is the height of cylinder B if they both have the same volume? So let's write down what we know. So we got cylinder A chilling over here, and he has a radius of 4 inches, and he's 2 inches high. So let's do a little sketch. Okay, so his radius is 4 inches. I'm just gonna draw a little radius there, and his height is 2 inches. And I know this isn't drawn to scale, but it's okay. It should be shorter and fatter, but whatever. We don't have time for artistic abilities here. So that's cylinder A. Now cylinder B, we're not really sure what the height is, but let's go ahead and give it a quick sketch. So cylinder B has a radius of 2 inches, and again, I didn't draw this to scale, but now it's kind of bothering me since I mentioned it, so maybe it looks a little bit more like that. It's a little bit smaller. And it has a radius of 2 inches, so let's put that right here. We don't know what the height of this guy is, but we know that they have the same volume. Okay, so these two have the same volume. Now, if we go back to our formulas, the volume of a cylinder is right here. Volume is pi r squared times h. So the volume of just an arbitrary cylinder is pi r squared times h. Okay, so the volume of cylinder A is going to be pi times the radius, which is 4, squared times the height, which is 2. So the volume of A, 4 squared is 16. 16 pi times 2 is 32 pi. I'm just going to leave it like that for now. So that's the volume of cylinder A. And the volume of cylinder B, we're going to have the same formula, but instead of 4 as our radius, 2 is now our radius. And we're not sure what the height is, so I'm just going to put in h for height. Okay. I can simplify this a little bit by squaring the 2, and I get 4 times pi times h, which is really all we know. So we know these two things, and we know that they're equal. So when things are equal, we can set them equal to each other. The volume of A is 32 pi. The volume of B is 4 pi h. So these two are the same thing. They're equal. That's what they tell us in the problem. So we can set them equal to each other. 32 pi equals 4 pi h, and I'm trying to figure out what the height is. So on the right side, I can divide everybody by 4 pi because it's just multiplication. And these pi's cancel out. 32 divided by 4 is 8. So that is my answer here. That is my height. And we are in inches, so it's going to be 8 inches.